is this interesting concept called generative business intelligence, GenBI for short. I want to hear what is your take on GenBI and how is it different than the current tools that we have today and our current understanding of business intelligence and AI?
Yeah. Well, the difference is that nowadays you can easily take Claude and create basically a chatbot with tools that can access your database, query your data, and you can just ask questions about your data. So I'm imagining like I'm in the C-suite, I'm an executive, and to have this tool to create dashboards for a presentation or something. So this is where we're at right now. But this is still, let's say, manual. It's not taking full advantage of AI's capabilities nowadays. Because like what I could do is ask a question about revenue. It will find the tables, it will plot some charts, and I can just click in a few places and create a dashboard about revenue, let's say, and EBITDA. So this is, but with Gen AI, I could just automate having a real analyst exploring the data and telling me things I don't even know about data. So it's not just about showing you the data, which is basically what Tableau or Looker or Power BI are already doing. They're just showing the data to you. And then you have to reach some kind of conclusion out of the data that's shown. But in GenBI, what you could have is like asking assigning basically an investigation task to the agent and say, okay, can you look how our current logistic routes are optimized for the change that will happen on Monday on the gas price? And basically the agent will go into your data and will find a lot of context in the data that is something that we can also bring humans into the loop to document. And basically it will generate a report and it will give you automatic insights about what you should actually, it will give you more information about the data and what you should look into the data. It's basically in the manual process, in the Power BI or Tableau or even with AI in it, you're still required to add a bit of guts to it. And in this case, it's trying to discover insights for you. And it's trying to basically bring out issues that it can see from your data that are relevant to your business. And so it's basically like you can eliminate that gut factor and completely switch to a data-driven kind of understanding of your business. So for example, I was making this example of, I was asked to, a delivery app that I worked on, I was asked to make a predictive algorithm because when they went with their guts, they were thinking that, so they had this company OKR that was really important to reduce because it's related to the quality of the company itself, which is cancellation. So if you have a delivery app, one of the metrics that you really important to show to your investors is that you can reduce your cancellations, right? That summarizes a lot of things of the company. And so they they applied the Pareto principle and they said, okay, so we have that most cancellations are caused by a segment of cancellation, which they called self-cancellation, which just meant that the customer actually actively canceled the order. And it wasn't canceled because of some logistics problems or the store's problem. So if you think about this problem, like they have cancellations, right? This can have many possible actionability points. So on one side, you could send a coupon to the customer and maybe the customer ordered a pizza and it's the delivery time is too long. It's like 40 minutes. And so the customer just gets bored, cancels the order and goes make a sandwich. So this is one scenario. And how do you solve this? You send a coupon and say, oh, look, it's taking longer, but you're going to have 30% off. This is one possible action. Another possible action could be to work on the routing algorithm. So maybe there was a mistake in how you assign the order to the wrong courier. So if this courier is really slow or whatever, it's causing the cancellation. And so maybe you should, another course of action could be actually to work on the routing algorithm of the app. But in this particular case, in which I was working on, I actually made the algorithm to predict with a really amazing precision which customers were going to cancel the order from the customers that were going to get canceled because of the other issues, but they didn't actively cancel, and also from the orders that actually were delivered. So the algorithm was incredibly precise at pinpointing exactly which customer would eventually cancel the order. And when you looked at it, and this is where model explainability comes in. So before I was telling you about feature engineering and how they can be automated with deep learning, for example, and in the case of the handwritten digits, they can be automated with convolutional neural networks, which are basically trying to reproduce what the human retina does for recognizing objects and stuff, how the human retina creates this kind of um, important patterns to be able to recognize quickly without examining every information in the image. But what I was going to say before is that uh, this makes the whole process become a black box, because in this case of the ugly numbers, for example, that I mentioned before, the human retina is doing it, but you don't know it's doing it, right? You just see a six that looks like a seven and say, oh, it looks more like a six than a zero. But you don't really know what happened in your retina, right? It's the same thing with deep learning. It's doing it, but you don't know how it did it. And there's a part of machine learning that deals with this problem that is called model explainability. And it's trying to tell you mathematically how the algorithm is correctly predicting stuff. It's taking the model, analyzing, testing it, and telling you this is how the algorithm reaches the conclusion that this is a correct result. So this is how the algorithm is telling you that this is a six and not a zero. It's looking at these pixels. In particular, it's looking like if they're close together at this point or not. So what I did was, in this case of the delivery app, I applied model explainability to the cancellation to understand why my model was working so amazingly well. The insight was that it wasn't a routing problem. The company didn't need to spend any money giving coupons to customers. It was just a UI problem. They just had to put a pop-up screen into the app so that the customer wouldn't panic cancel their orders. And the whole problem, the feature that revealed this was that the people that self-canceled, the great majority of them were self-canceling almost instant after ordering. And also they were reordering the same order after a few minutes with a small modification. So basically, this was thanks to model explainability, because I had a perfect model. We could have put them in production. We could have given coupons to those customers. But if the customers were just canceling their orders because they made a mistake, you were just wasting away a coupon.
That's insane. Now you essentially save the company millions because you multiply the value of the coupons over time. That that can add up to a large amount of money, especially given the customer base that this company had. You save them millions. You were able to identify that just a window, a confirmation window, or a summary page, something like that, was going to be more effective than reducing the price of the total order with a coupon because you applied model explainability, essentially. Imagine and that's just like that's that's one point in the customer journey, in this case of a delivery app. That's just the final point, actually. or if not the final part, one of the last points. Imagine if you apply that at every point in a customer's journey, or if you take a different company that has a different flow and scenario, like you just apply that kind of model explainability thinking or just context to see if, hey, are we solving the real problem here, or are we solving the problem we think that we're having?
Exactly. So, but this was before ChatGPT and all of this came out,
This was
before
before. So
LLM
imagine
became a
today.
thing.
Yeah, imagine today.
But and the point is that after I did this, I documented it in Jira, and so it got documented somehow. But then when I moved on from the company, I think they lost the information completely. Also, like what I documented in Jira was the mechanism, but I didn't document, for example, some transformation that I did to the data to arrive to that conclusion. And first off, that those transformations stayed in my laptop and were basically deleted when I left the companies. And so what I'm saying is that these kind of insights and this kind of transformation should be documented with the data. And so when the AI is actually looking at the data, the AI becomes has a lucid, a clear snapshot of the situation, and is considering that kind of context when it's specifically looking at that data. So you don't need to specify it in the context. What you would do, like in a phase one AI transformation with agent, is that you would feed the whole Jira to the AI. AI would find the article that I wrote in Jira and the other article that the UX analyst wrote in Jira. Maybe there were some things that were confusing. And so maybe it's going to mix that one with other stuff. And it's not going to scale very well. I think the hallucination scale with the AI itself. So what you want to do is to actually create this huge filter and embed the filter into the data and into the context that the AI examines in real time. So when the AI is actually trying to respond to your question, which is called inference. So at the inference moment of AI goes through a first filter, which is a context layer, which aims the AI intent exactly where you want it to go. And this way, I think you can basically, instead of having a chatbot that can actually create dashboards for you, you answer questions about the data, but expecting to keep investigating manually on it and to keep specifying the context. Instead of having this, you could actually end up having an agent that is giving you insights like these automatically.
How and final question before we jump off, but like, is that something that you can easily update? Because over time you get new context, new information. I guess you can once you instruct it or build it out at the infrastructure level. Once you build it out once, the maintenance of it, is that something that is that going to be a new category of work for people of like maintaining that context? Or is that something that's kind of done once in a while periodically?
So what happens here is that unless you want to drown into creating metadata for your company, you have to switch from a traditional infrastructure for data to an infrastructure for data that is more based on semantics. So, and that gives you the key to developing this infrastructure in which AI can actually work. And what you would do is you would have your workers maintaining and supervising and governing these infrastructures. So your knowledge workers would actually maintain and govern this infrastructure and supervise them because at some point they would be put in the loop of
I think
some decisions and stuff.
yeah, so that's okay. So that does create a new job, kind of a new responsibility for knowledge workers when they're
And also for data engineers, because what happened, and also for infrastructure in general. And so the whole responsibility is to actually create the guardrails for the AI actions, the agents, and to uh, to govern these context and to make sure that it sticks to update it, basically. That will
Yeah.
be the real work. And then you can basically unleash AI on it. And you can make, and you also, like in the Palantir system, one of the main rules is that you can safely assume AI is going to make mistakes. It's just that you create the safety net. And first off, through the context layer creation, you're making sure that AI makes the best decision and has a filter scope at every moment it is, let's say, synthesizing the information that you give it. So you make sure that AI has a clear in mind that an AI with too much information. So I'm telling you this because I read a few articles recently about companies that still stuck with a traditional data lake model, and they had a pristine data lake model, and that takes an incredible amount of time to build. It's really a huge effort on the engineering side for the company. But what you can do instead of that, and so that is all like money that went to garbage, because you can put, like, as I said, like a chatbot, like you can take Claude and put it on a pristine data lake and it will still make mistakes because there's too much information, because you're not filtering it, thinking in its way. Like if you think about humans, maybe the only advantage we got left over AI is that we have more reality context than AI. And so we, without realizing, the same way you don't realize your retina is applying this convolutional layer and creating features about objects that makes you instantly recognize objects without examining the whole image in the retina. The same way you don't realize you're doing that, this is the similarity between feature engineering and context engineering, is that you are also adding extra context without even knowing it to your actions in a company, in your daily life. But now we're talking about a company. So you don't realize that you're adding a lot of context. So your responsibility becomes, so the AI, the Palantir is saying, one of the main rules is that AI shall make mistakes. We never assume that AI won't make mistakes. So your responsibility is actually in the system, in defining the system in which you can unleash your AI and take a full advantage of its intelligence, making sure, first off, that at every moment has the freshest snapshot of reality. And at the same time, the actual important decisions are filtered. So you have a context filtering that is the context layer embedded in the data. And you have an action filtering in which the AI eventually will just fill in a form in the system and say, I suggest these actions should be executed, but it's not actually executing anything. There's an extra layer, which may involve a human, that first there's an extra layer that has a strict protocol about actions and only has a tightly bound finite set of actions it can perform. And if the AI totally passes that, it can be executed because it's a standard action. And if there's any anomaly, it will just put a human in the loop. And that way you can fully unleash the power of AI and getting these kind of situations in which you say, okay, I want to reduce the cancellations. What can I do? And the AI will tell you, okay, looking at this, there's 3 ways to go about it: coupon, improve routing algorithm, or something else. Let me look into the data, blah, blah, blah. It will run this model and will tell you, oh, look, this is actually a UI problem. And that's the only way you can arrive to that kind of scenario.
think this is a great way to end.